Hello my esteemed listeners. In this tutorial we will clearly discuss the merging and the merging of sorted arrays. Whenever merging is done on two arrays, it will be amalgamated into a single array. And thus far, in order to have a recall memory, we have done several manipulations of an array, and we did these manipulations in order to drive out some useful informations from the array. We did initialization and duplication, and we explained the accumulation of arrays into a single element, the reversing of an array, arithmetic operations on array mostly concerned with statistics, sorting of an array, and we have implemented bubble sort and selection sort, searching of an array. We searched for an important element called key in an array, and we did implement two famous methods. One is the linear search, other one is the binary search. And in this tutorial we will discuss the merging of arrays. And of course all these tutorials are devoted to one-dimensional array. So we have merging in two viewpoints. One is arbitrary merging, the other one is merging of two sorted arrays into a single array. Suppose arbitrary merging goes like this. Suppose A and B are the two arrays of size n each, and if we want another array C, okay, to be consisting of arbitrarily merged arrays A and B to contain elements, and this is the thing we are doing as an example. C has its first element A of 0, the second element B of 0, the third element A of 1, the fourth element B of 1. Like this, one element each is taken from A and B progressively, and they are placed in the array C progressively, while C consists of 2n number of elements. Okay, that is sum of n elements of A and B. Now C is the array. C has to have an index which will go in this direction, and A is an array consisting of 8 elements, B is an array consisting of 8 elements, and what C should get is 16 elements. And A of 0 will go to C of 0, and B of 0 will go to C of 1, and A of 1 will go to C of 2, like this, so on and so forth. And A of 7 should go to C of 14, that is the last element of A should go to the 14th place of C, and the last element of B should go to the 15th place of C. Okay, anyway, we will implement this. A consists of 20 elements, B consists of 20 elements, C should essentially consist of 40 elements. I and K meant to be loop indices, and N is number of elements found in A and B. So enter the number of elements. So the user is directed and he will enter number of elements, and enter percentage the elements of an array. If n is 6, it will just echo like enter 6 elements of an array over the screen. And this program, this portion of the written program is totally to make our executed program little interactive. And merging is done in this loop. K is set to 0. This for loop will go up to n, I equal to 0, I less than n, I plus plus. C of 0, k is 0, C of 0 equal to A of 0, K will become 1, C of 1 equal to B of 0, K will become 2, C of 2 will be equal to A of 1, and K will become 3, and C of 3 will become B of 1, and K will become 4. Like this it progressively moves. After the completion of this for loop, what we have in store in K is n plus n, that is 2n. So now we will print the merged array. So I equal to 0, I less than 2n, I plus plus. We could have also placed K over here because K has to contain 2n elements. Printf percentage 3d CFI in order to create space when we print the array, the elements of array C in a line, we have this format specifier. And here is an example. After running the program, enter the number of elements 5, enter the 5 elements of an array 1, 2, 3, 4, 5, enter the 5 elements of an array B 6, 7, 8, 9, 10. Since it is arbitrarily chosen, this is not a sorted array anyway. So C of 0 equal to A of 0, C of 1 equal to A of 0. Like this it goes 1, 6, 2, 7, 3, 8, 4, 9, 5. Okay, the elements are alternatively drawn from A and B placed in C. Now this is second kind of an example of merging, where two sorted arrays are merged into a single sorted array. Okay, this trick is used in the famous algorithm called as merge sort. Okay, here is an array consisting of 1, 2, 3, 4, 5, 6 elements, 10, 12, 14, 15, 25 and 28. We can see that the elements of this array is sorted, and the elements of array B is 5, 7, 23, 32 and 46. It is also sorted. And this is the completely sorted array after having drawn elements from A and B with progressive comparison. In order to compare, we need an index. Index I will move over array A, and index B, index J will move over array B. Okay, and the array A, the element 10, that is element 10 from the array, is compared with element 5 from array B. Since 10 is more than 5, 5 will be placed over here. Okay, since the element is plucked from array B, this index has to move further. It has to go to 7 because 5 is no more there in array B. It has to go to 7. Anyway, 10 is compared with 7 again, and 7 is lesser than 10, therefore 7 will be placed over here. And this index will further move. It will come and sit beneath 23. Now 10 is compared with 23. 10 is lesser than 23, therefore 10 will go over here. Similarly, it will happen to 12. It will happen to 14. It will happen to 15. Then the index will come over here because 12, 14 and 15 are progressively plucked from A, and I will go and sit beneath 25. So this 25 is compared with 23. Since 23 happens to be lesser than 25, 23 will be moved over here to C. The J index, which was over here, will move beneath 32. Now 25 will be compared with 32. 25 is lesser than 32, therefore 25 will be placed over here. And then 28 is the same thing which happens to 28. 28 is compared with 32. 28 will be placed over here. Therefore array A gets exhausted. I will come to this particular position. I will come to, if number of elements in array A is m, then I will come and sit at m minus 1th position. After sending 28 to this particular array, the merged array, there is no place for this I to move further. Therefore, whatever that remains in B will be poured into C. Okay, 32 and 46 will come and sit over here. Okay, in order that this situation will happen, I will become equal to m. On the other hand, if array A were to be array B and array B were to be array A were to be array B, of course reverse would have happened. Okay, array B would have got exhausted, and whatever that remains in array A is to be poured into C because both the arrays are sorted. Okay, so K is the index which moves. K will be equal to m plus n. If this is m number of elements and if this is n number of elements, what array C contains is m plus n. So integer A, and this is the implementation. Integer array A 20 elements, array B 20 elements. Therefore invariably C should have a storage space for 40 elements. Okay, I, J, K, they are the loop indices. This is also loop index, we will see later. M is number of elements in A and n is number of elements in B, and temp is a variable that is set forth in order to implement bubble sorting, because arrays are to be sorted first. So how many elements A contain? M. How many elements B will contain? N. Okay, now enter the elements of array A. So all the elements of array, all the m elements of an array is entered into array A, and all the n elements of an array is also taken as the input, and they occupy the memory respective places named A and B. Now sorting of an array A, we have implemented bubble sort. As our respected viewers will be able to guess this, m minus 1 iterations and m minus 1 minus I passes, and A of j is compared with A of j plus 1. and it is swapped. If this comes true, and if you are arranging things in ascending order, therefore swapping will take place. So what comes out after this for loop is sorted array A with m number of elements. And after this, what comes out is sorted array B. Of course, this should be made as B. Sorry, this should be made as B. Okay, the B array. So what comes out after this? After this is B array. Okay, completely sorted in ascending order. So now we will have, after this loop, we will have two arrays that have been sorted. Now merging will take place. We will set I, j and k equal to 0. This is called as multiple assignment. I is an index which moves on array A, j is an index which moves on array B, and k is the index which will move on the array C progressively. Okay, this condition should be true because both I and j has the limits. I can move maximally up to the place, okay, numbered m-1, and j can move as an index to a location which is numbered n-1. Therefore less than n, less than m. Okay, if a of I, the element contained in A, is lesser than element contained in B in the ith position and in the jth position, because I is devoted to A and j is devoted to B. Okay, therefore initially I is 0, j is 0. If a of 0 is lesser than or equal to b of 0, then c of k should contain whatever a of I has. So a of I will go to c of k, I will be incremented. The index, because the element is plucked from A, the index set forth for I, okay, under the 0th position will make a move. Otherwise what c of k holds is whatever that is there in b of j. So j will be incremented. The index, because if this comes true, the element that is found in B will be plucked and placed in C. Therefore j will be incremented. Okay, before we complete the while loop, k should be incremented in order to facilitate entry of the next element. Therefore k will culminate in total number of elements. So after the happening of this while loop, okay, this while loop, the control from the while loop can come out for two reasons. Either I reaching its last position in the first instance, or j reaching its last position in the first instance, or A getting exhausted with all the elements, or and B getting exhausted with all the elements, because this will never come true. Therefore it is false and true, or true and false. Anyway, any one of the things becomes false, the control will come out, and we will question it up here. If I equal to m, that means if A has got exhausted, then we will set forth, okay, because B would have remained at j, because j is devoted to B, j would have stopped at j because I has got exhausted. So it has to start from j. P equal to j, P less than n, because it can move up to n, because B contains only n number of elements, P plus plus. C of k equal to B of P. The remaining elements of B will be poured into K, and K will also get simultaneously incremented. If this is not true, that means B has got exhausted. Therefore, I was the index for A, so I has stopped at a particular location because it has not still exhausted. So it will start from where it stopped. Okay, P equal to I, P less than M, P plus plus, C of K equal to A of P, and K plus plus. So now after the completion of these condition, okay, after these conditions are checked, what we get is the sorted array, the merged array, I equal to 0, I less than K. Okay, because K will contain total number of elements, I plus plus, printf %6d cfi sch. Okay, this is in order to This is in order to print the array in a sparse way. Okay, we have a gap of 6 places. So now we have brought out a screen snapshot of a program that was executed in box code. Right. How many elements of A contain? 4. How many elements B contain? 5. Enter the elements of array. You can notice 2, 1, 17, 6. It is not in order, but anyway, we have not printed over here the sorted array after the bubble sort getting executed. Enter the elements of array B, 22, 8, 13, 18 and 7. Okay. Now the merged array is 1, 2 from this only, 6, 6, then 7, 8, 13, 17. Now A gets exhausted over here as far as this example is concerned. So whatever that is there in 18, whatever that is there in B after sorting, because this shows bubble sort has worked well. Okay, it contains 18 and 22. 18 and 22 are the elements in array B in the unsorted way, in the unsorted presentation. After sorting, 18 and 22 will sit beside, and they will come and sit in C. Okay, and that will culminate in the merged array. So you can notice that merged array is also sorted. So with this we will close. We will come to an end of the manipulations that could be done on an array and on one-dimensional array in particular. So in the next tutorial we will discuss some of the manipulations or some of the problems that involves two-dimensional array, namely matrices. Okay, so with this we will close this session.